Hello everyone. I'm super excited to be here and host this virtual webinar for you. And I hope you will enjoy it and learn a lot. And I will just jump in straight into the webinar because I have a lot to present to you and I have only 1 hour. So let's get started. I will start by sharing my screen. Actually, you can already see it. Awesome. So first, I will present you a few slides so I can set up the context of what I want to present regarding evaluation. And then I will jump straight into the code and walk you through the most critical parts of it. So actually, I want to start with a quick story. So let's just imagine that you just shipped your first AI agent to production. And then your clients or users or whoever are important to you start complaining and they tell you that the agent doesn't work, it doesn't behave as expected, and so on and so forth. So the thing is that you can't rely on people's feedback. I mean, you can rely, but you can't rely on debugging your system based on your people feedback. So you have to answer questions such as, uh, how can I take a look at the prompts, at the input prompts of the clients and the answers generated by those prompts? How can I take a look at the context generated by those prompts and used to generate the final answers by the LLMs, right? Basically, you need a good look and understanding of what's happening behind the scenes. And the thing is that normal logs usually don't work for this kind of scenarios. And we will see soon why. Also, another aspect of this is when you start shipping new features, right? So again, you shipped your first MVP and you start and you want to start shipping new features afterwards, right? Or fix new bugs and so on and so forth. And the thing is that usually you start tweaking with your current prompts, prompt templates, you start adding new agent, new prompt templates, or new tools, and so on and so forth. So the thing is that usually when you do that, you break other parts of your system. So you need to have a clear technique to measure the impact uh, of your new changes over the system, right? So basically, these are like the key questions that we want to answer during this webinar. And now let's dig into it and see how we can do that. Okay, so as I already presented to you, this webinar is called the LLM and RAG Evaluation Playbook for Production Apps. And I want to start by giving you a quick insights on how a RAG agent architecture looks like and where we kind of can evaluate and monitor it. So RAG agent architecture can basically be split in two big components: the RAG feature pipeline or the RAG ingestion pipeline that takes in data from a specific data source, process it, and load it into your memory, which usually is a vector base, but a vector database, but it can be anything else, right? And on the other side of the spectrum, we have the agentic RAG inference pipeline, how I like to call it. But usually here is where you have all your agentic logic or LLM logic or and so on and so forth. But the thing is that if we dig further into the system, usually we have five important components that we want to usually evaluate, monitor, or isolate, right? So we have, as I said earlier, the RAG feature pipeline that take raw data sources, processes them, cleans them, transforms them into chunks, then embeds them and loads them into the memory. Then we have the memory itself, where we have long and short-term memory, on top of which we have the retrieval algorithm, right? So basically here in the memory, we care how the data is stored and how it's retrieved. This is the second element that we care about. The third element, as I said, is the agentic logic itself, which is usually built on top of the memory. So here we care about how the agent decides, for example, to retrieve data from the memory or just rely on the internal logic of the LLM. Next, we have the LLM API or hosted LLM or something that runs directly on the machine, or it's not that important. The key is that we also care about isolating the LLM itself and see if it behaves as expected. And the fifth element is the observability pipeline, which is actually used to help us monitor and evaluate the whole system. So observability usually has these two components, monitoring and evaluation. So after we isolate these components, what do we care about and what do we want to evaluate? So as I said, we have the RAG feature pipeline, the retrieval step, which is where for RAG you have the ingestion and the retrieval, and you should evaluate and monitor them independently and together as well. Next, we have the agentic layer, as I said, that usually uses specific tools. You don't necessarily have to use a tool that access your memory, right? You can use like a web tool or an email tool or a calculator or whatever makes sense for your application, plus some routing or whatever logic you have inside there. Usually you want to evaluate this as a whole. And then the LLM API, you also want to make sure that it's good enough for your use case. So if we dig in a little bit further into each of these components, for example, for how can we evaluate the RAG feature pipeline or ingestion pipeline? So we can further divide this into smaller pieces of logic, right? And take a deeper look. So for example, usually at this step, if you work with PDFs or similar documents, you want to run an OCR. So you're interested like in the quality of your OCR. Or you should always play with your chunks, especially the size or how you extract the context and so on and so forth, because ideally you want to catch a single entity per chunk. Also, you care about your embedding models, right? So as you can see, you have many pieces that you should isolate and evaluate independently. But in reality, it's very time consuming to do that. And that's why a very quick approach to actually see the quality of your embeddings is just to visualize them, right? So you plot them using techniques such as UMAP, you plot them in 2D or 3D and see how your chunks look inside the vector space. Next, we should take a very careful look at your retrieval step. Here, we kind of can take two approaches on how we evaluate this retrieval step. So we can either use LLMs judges to compute metrics such as context recall and precision. Here, I like to have this like 4 core entities, right, that we usually have in any LLM RAG application. So you have the query, which retrieves some specific context, and based on that context, you generate an answer, right? And based on these 3 elements, plus the grounded context, you can compute this context recall and precision metrics and answer questions such as, okay, is the context enough to answer the query question? Or is the context correct relative to the query context, right? And if we also have the grounded context, we can respond this answer even better. But if we have the grounded context, we can go even further and compute ranking metrics, which are usually taken from the information retrieval space. So we can leverage metrics such as MIR and other metrics that are usually used in recommender systems, where their goal is to see if all your documents that are retrieved from the vector DB are ranked correctly, right? Because LLMs are very sensitive to how your information is ranked inside the context window. So basically, that's what you want to measure with these ranking metrics. In this webinar, we will take a look only on the first 2 because creating some ground truth was quite tricky for this webinar. Okay, and the next step that I want to show you is how can we evaluate the whole agentic app as a whole. Usually, I think you can see this very intuitively as integration tests inspired from the software engineering world. As for the other 2, you can see them as unit tests. Yeah, if that helps you create some intuition behind this. So here for evaluating the agentic app Actually, I should edit the title, how can we observe the agentic app? Because usually the first step is to monitor your traces and add prompt versioning on top of your whole system. And then you can start thinking about computing metrics using LLM as judges, which can be either offline, right, during your development, and online during the monitoring, and compute metrics such as hallucination, moderation, answer relevance, and so on and so forth. I will dig deeper into this while we develop the code. And the last step is the user feedback, which can, again, I think can be like internally, where you use like your current team to flag good and bad prompts, and also what we expect from user feedback from the actual users that use the application. But was really impossible for this webinar to show you, so I will show you how you can like get a sense of this by implementing a quick user feedback for your internal team, right? So this was it for the slides. I want to conclude this with some potential tools that can help you implement this evaluation as observability layer quite easily, actually. So in the open source family, you have Opic, Langfuse, and Phoenix. I usually use Opic, but I think all these three are good choices. And in the closed source world, you have Langsmith if you use LangGraph and LangChain, a Galileo human loop. And as I said, I usually use Opic for no pure reason. I just picked it because it's really hard to choose a tool nowadays. I just picked it and I liked it and I stick to it. Okay, so as I said, now for more similar content, you can actually go into this Phila Agents course which I used for this webinar. Like I picked only the observability part of it. So if you like it, you can check it out. It's free, open source, and has like 6 modules on production ready AI agent stuff, written plus video lessons, or you can subscribe to Decoding ML and LinkedIn for more similar production ready AI content. And now enough with the slides, let's dig into the code. So I want actually to really start this as raw as possible and just set up this from scratch together with you, right? So go into the repository linked into the abstract, go to this link, which I just clicked. And here you will see the solution and the template folders. So the solution, as you can imply, has like the whole code that it's already implemented and has everything end to end. And the template where I left like a few placeholders that we will implement and focus on and develop together inside this webinar. So you go into the template and clone this. Both are like independent Python projects, Python modules that you can run on your own. So you don't have actually you don't need the rest of the repository. You can just take this template and start from here. But because this is the easy way, I will just clone this one, the whole repository, and start from here. But afterwards, I will just open in my IDE just the template repository, because as I said, it's an independent and standalone Python project, so it will be easier to work like this. So I open it in Cursor, but you can use any other IDE that you like. So it really doesn't matter. So starting now, I think we can just stick to the IDE world and and start working on this project. So we use UV to install our dependencies, but I just laid out a really step-by-step tutorial into the README on how we can set everything up. So to be easier to follow, I will just copy paste the command from here. So to install the Python dependencies, we'll just use UV sync, which will install everything like really fast. That's why I like UV over pip or Poetry or everything else to install the Python dependencies and manage the project usually. So the dependencies are over here in by project.toml. And next, that just to check that we installed the right Python version. So UV also installs uh, the right Python version scope at your project, which is again extremely nice. We specified it in this Python version file. And yeah, basically we are set up with everything, Python dependencies and all of that. We are ready to go. Now, as we use OPIC and the OpenAI API, we need some credentials. So this is the only time, the only step where I will reference my already working solutions, and I will just do a copy paste from there for my end file because, of course, I don't want to show you my keys, right? So just 1 second to find it. And we'll be back in business. Okay. So you can actually have, you should just copy this .m.example file and fill in these two environment variables. And yeah, that's it. And then everything will work out of the box. But I won't do that. And I will just, as I said, copy a already pre-filled .m file. Okay. So here we also have like the project structure. I won't go step by step into what happens here, but it's very important to highlight that this is not like we don't start from scratch here because we want to observe an agent that already does something, right? So for that, I already implemented a basic agentic RAG system implemented in LangGraph, which based on the Philo agents course I referred to earlier, uh, basically impersonates philosophers. So what it does, it's a basic agentic RAG system that we populate the memory by scraping Wikipedia and other sites about facts about philosophers. And we did some prompt engineering on top of this to impersonate specific characters such as Socrates, Plato, uh, and so on and so forth. We have like 10 philosophers. And basically, we can chat with them, and based on specific characters, they have different personas. And we have this memory with this factual data about each character, where when they have to respond to questions such as, hey, tell me more about your work, where were you born, and so on and so forth, they should, in theory, retrieve data from the memory instead of relying on the LLM itself. And we will use these techniques to actually check that we retrieve this data from the memory and don't hallucinate. Okay, so yeah, let's start moving forward. So that's why you will see here in the source directory quite some code. We don't have time to dig into everything that's going on. We'll focus just on the evaluation. But some key parts of this is that here in RAG, we have RAG related files implemented in LangChain to keep it like simple. And in the workflow file, we have the LangGraph code, which implements the agent. And in the evaluation folder is what we will implement now. And in the domain folder, we have the philosopher entity and other related files like the prompts and so on and so forth. So the next step is to set up the infrastructure, which we used Docker to set up a local quadrant. As you can see, I don't use notebooks. I don't think that if you want to go to production, should start even with notebooks. Like I get it, that is good for exploration and all of that. But otherwise, I think they just make you slow. This is my personal opinion. Okay, so I use Docker Desktop to check that everything works fine with my Dockers. So the quadrant vector DB will run on this port. If you already have it used, make sure that you kill it. You kill any other application that runs on that port and spin this up. So you can spin up this vector quadrant on top of it. And yeah, this is our agentic RAG. So we have just a conversational node that has a tool to access the memory. And yeah, that's it. As I said, a very simple agent to observe, evaluate, and monitor. Okay, so that was with what that was everything with the setup. And now what we should do is first to populate the quadrant memory, right? So we use make to wrap all our commands. So we have nothing fancy, but instead of typing all the time all these commands, we will just use make to wrap them up into simple one-liners, right? So basically this will, as I said, scrape Wikipedia and other sites to gather information about our philosophers. Uh, in this live webinar, we will use just three. So we will use Plato, Aristotle, and Turing. Turing is not really a philosopher, but it was an interesting uh, use case. But we support like up to 10 philosophers if you want to make it more fun. Okay, so after the vector database populates, we can go to the quadrant dashboard. Okay, so this link doesn't really work, but you should be able to access the quadrant dashboard in theory at this port. So if you run localhost, the port of quadrant and dashboard, we'll be able to access the dashboard quadrant from your local database, right? So as you can see, we can see the philosopher long-term memory collection over here with around 1000 points. So this means that yeah, everything ran fine. Okay, so basically we are all set up. A final sanity check to see that everything works fine is to basically call an agent, right? So let's ask Plato, when and where were you born? And also tell me about your life, work, and beliefs. I especially formulated these multi questions because our goal is to see that the agent can actually like understand that, okay, I need to answer multiple questions, decode them into multiple questions, and first make a query for when were you born, then retrieve from the vector database where were you born, and then ask some questions about your life, work, and balance. So if we won't have monitoring and evaluation in place, this is actually quite tricky to test, right? You see this in the in your terminal, right? So it's quite tricky. You can of course, you can also print out everything that is going on in your terminal, but to be honest, personally, I think it's really hard to understand what's going on inside there, or you lose a lot of time to go through all these logs and debug it. So that's why we need to do this smarter, right? So we need to use specialized tool that actually tracks all of this and makes digging into your prompt traces and what's going on, basically make it easy to open up the box, right? So that's now we will start into the actual implementation, and it's split into 4 modules. The first one is to do this monitoring step. Okay, so to do that, first we have to set up OPIC. We'll do that with OPIC, as you probably thought. Okay, so just let me select my Python interpreter so we have autocomplete. Okay, that's done. So the first step is actually to configure OPIC. I already done that for you because it's really nothing interesting. You just need to call some configuration methods, which you can find into the documentation. So I do not want you to lose time with that. And then the next steps are to actually add this monitoring on top of your agent. Just as a quick highlight, I added to-dos everywhere you need to add code, some code snippets, because we don't write this from scratch. We just look into specific parts of the application. So based on specific models, I added these to-dos over here. So basically, if you fill out all these to-dos, you wrapped up the webinar. But I won't follow them like this because I want you like to follow the actual code. So if I just click there, I think everything will be fragmented in our minds. So I will just follow the code structure and my logic as I was programming this from scratch. So I want to monitor the agent itself, right? So then I go into the workflow folder, and in the graph folder, we actually define the actual agent. Okay, so not here. So here in the agent, so here in the graph, actually, we define the graph builder, and we call this create workflow graph from the agent file, right? So here, as I said, we create that create workflow graph. So we have the graph builder. Now we build the graph, and then we want to call the graph. Well, when we call the graph, we just need to put actually this callback from OPIC, and that's it. We have monitoring. Okay, this is really easy because of LangGraph and because OPIC knows how to track each node. But if you have like more granular things, you can also do that, like monitor specific functions and all of that. But again, that's really easy to implement, and I want here just to get a sense of what to monitor and why is this important, and then you can, it's really easy to go into the docs and further refine this. We also have a call function and a stream function because based on our use case, we either want to just generate everything from one shot or stream these results. This will work in both scenarios, also streaming and normal calls. So this is important to highlight. Okay, so this is it. Now we have monitoring. Just let me check if we have anything else into the module one to implement. Okay, so to configure OPIC, we actually have to call that function, which basically calls the API key and sets up the workspace and all of that. So now let us call the agent as before. And as you can see before, it said that can't use OPIC to blah, blah, blah. Now, okay, it still says that because this refers to the prompt versioning, but it also says that OPIC configures successfully using workspace Iusztin poll. So now let me just open OPIC. And let's see how this prompt looks like. And it takes so much time because I also started rendering the LangGraph graph, and I realized that starting from today, for some reason, that function doesn't work anymore. So I just, so it just tries to render it, and it uses some Mermaid API, and it has like some retries in place, and that's why it takes so much time. So I just comment this so we don't have to wait that much in future runs. So just 1 second, and let me log into the right OPIC account. Okay. So I just log into the right OPIC account, but then you can also just click this link, and it should open where it should. So, okay. So it opened here. We have, so I already ran some traces, but if you order this by the start time and just open the last one, you can see that this is from today. So let's open this one. And here, voila, you can see everything that happened inside the agent. So here at the top level, we can actually see the query that we asked and other context used as the initial input. And here we can see the final output. This is the final answer, like I am Plato, born around blah, blah, blah. And we can also see the content and everything else that was used to generate the final answer. that we can see here in the CLI, right? Okay, so now the question is, okay, how did we retrieve this content? How the hell did we compute it, everything from here, right? So that's why it's not useful to log only the final output, but to actually log everything that happens behind the scenes. So next, we can start and dig into each node. For example, we have the conversation node, and we can see the specific input and output of that specific node, and we can even dig further into what happened inside that node, like the actual OpenAI call, where we can see how much that specific code took, how many tokens it used, the cost, and so on and so forth. And next, we can see that it decided to use some specific tool, which in our use case is the retrieve philosopher context. And we can see that inside our code, this tool was called, and for this specific uh, hmm, for this specific query, we got a specific answer. But we can already see that we wanted to know more about Plato. We wanted to know also where it was born, when and where was born, but also wanted to know more about his work. So it means that this doesn't really work as expected, right? So we found that quite easily. And then based on this output, we have the conversation node called again, and so on and so forth. So the idea is that we can now really easily follow what happens inside the agent and also understand how long it took to answer all these questions and go through everything, the number of tokens it used as input and output, the cost and everything, just at a glance, right? With one line of code. Okay, so this is monitoring, basically monitoring prompt traces. So as I said, implementation wise is quite easy. Even if you want to write it more custom, you need more than one line of code, but it's not that complicated. Okay, so now to move on to module 2. Okay, so just let's use the ID. For module 2, we want to quickly evaluate the ingestion step, right? So to do that, because we have to stick like to 50 minutes, I implemented just the visualization, right? And usually, in my opinion, this is a really quick win to visualize your embeddings, basically. So Quadrant makes this really easy. You can just go to your Quadrant collection, hit visualize, you will have this dashboard. You go here to run, you enter command or control enter, and boom, you have this. So now here you can start looking at your vector space and start to get a sense of it and start to understand that if your embeddings make sense. For example, we can quickly see that here we have our Alan Turing cluster. Here we have our Aristotle cluster, and again Aristotle, and here we have things about Plato. So we can see, for example, just at a glance that, okay, Aristotle and Plato, because they're Greek philosophers, they write kind of in the same space, but Plato is more over here, and Turing is completely from another scenery, right? So these embeddings make sense, but as we can see, we have many data points that are really overlapped with each other, right? So because we scraped like multiple sites per philosopher, we assume that we also have duplicates. So we make just a really simple tweak to our data ingestion pipeline where we want to deduplicate the chunks, or at least try to deduplicate the chunks. So I actually go to this long-term memory file, and we have here this deduplicated documents line of code, where basically we implemented min hash to find similar chunks with each other with a threshold of 0.5. So our goal here is to deduplicate these similar chunks and make the memory more clean and avoid redundant information, which is really important because, for example, if you query when Plato was born and you have 3 points that are duplicated and you use just 3 points as your context, right? We will just retrieve actually the same information 3 times instead of retrieving 3 documents that complement each other. So having clean data inside your vector database is important. And this is where just a simple visualization can help you really easily. So basically, we are just recomputing the collection from scratch. I'm just deleting everything and recomputing everything from scratch using this deduplication. And most probably, we implemented this quite naively. So as you can see, we still have many duplicates. But I did this, to be honest, just to show you like how this works. So you have this visualization and you start changing things in your ingestion pipeline, and you can rerun the visualization and see if it actually helped you or not. So this was the scope of display. Uh, as you can see here, it did not done that much, but we don't have time like to actually investigate every bit of this implementation. Okay, so here is min mesh. You can search out how the actually min hash algorithm. You can search the internet how this works. We used data sketch to use the min hash and min hash local sensitive something to implement this. Okay, so the next step is to start at the retrieval step is to start playing around actually computing some metrics, right? So as I said, at the retrieval step, we also care about computing the context precision and context recall metrics using LLM as judges. But the thing is that you usually compute this relative to your input, retrieve context, and output, which means that you need to call your agent to see what context it retrieved to actually compute this. And when we use a similar technique to compute other agent-related metrics, and that's why we actually here in the evaluate.py file, we all overlap module 2 and 3 together because they kind of have the same implementation, give or take. So starting with this, as we have only 20 minutes, I will just start to copy paste pieces of code so we can move faster while I can also explain what's going on. Okay, so actually, let's start with uploading the data set, the evaluation data set to OPIC. So to do that, we will copy these lines of code, which basically, where we basically do the following. We load the evaluation data set from JSON because this one is quite small, so we can store it in JSON. We have this evaluation data set, which we showed how to compute automatically based on our memory and our specific data of philosophers automatically using LLMs. We showed that how to do in the Philo Agents course, but here we don't have time to do that. But the key idea is that we generated 3 conversation turns between a character called Sophia and a specific philosopher. And we will use the 2 turns as context to build up the conversation, and the last 2 conversation turns as the final input. Basically, this is the final user input, and this is the ground truth output. So we expect this output because remember here, we enforced the right context when generating this. In the agentic workflow, we don't know if the agent retrieves the right context from the DB, right? So we upload these data sets to OPEC. We just laid down the data set in the nice format, basically in this one. And here we basically take this Python dictionary and send it to topic. So nothing that interesting. But to do that, we have to run this function. Okay, so this one fails because Opic updated their something, and we have first to delete the existing dataset. I already have a dataset, so I have to delete it. And now we have to push it again. Before I implemented this webinar, they just let you override it, but as you can see now, it worked. So now we have the fresh one. So we go here, and as you can see, basically you can see the data set. You can click on a specific sample, and you can see the same thing as in the JSON files. So now let's go to the evaluate.py file and start trying to compute some metrics on top of this data set. So in the data set, basically we have the input and expected output, which is like the ground truth. Now we want to call the agent on top of these inputs and compare the generated output with the expected output and compute some metrics. Like if you think about it, is the same as in classic machine learning, but here we use LLMs judges to compute the metrics instead of using plain Python. Okay, so again here I will start just copy paste lines of code to move faster. So first we need to get the evaluation data set that we just moved topic. We do it like this. So we just call a get dataset function with the name, and that's it. Next, we can also store. So here we will actually do some experiments, right? So we call this data set and compute some specific metrics, similar to like doing experiments in machine learning, like using experiment trackers to compute multiple experiments with losses or other metrics we care about. But this is not training, right? This is just the evaluation step that we do during training or after training. Okay, so we do some metadata because we care about like what model did we use when we called the agent, what data set we used, and everything else that we care about. We can also track the prompt used while we call the agent. So to do that, we have to explicitly say topic what prompts we use doing this. So we know that the prompt that we use here is called like this. So this is hard coded because we already know this is a constant. And so I will show you how this will look like in the UI, where you can see this stuff while along the metrics and everything else. And now let's define the scoring metrics. So here. So for this example, I want to focus just on the retrieval stuff, which is context recall and context precision. And now what we have to do is to wrap all of this inside a single function where we call the data set. This is the function that defines how to call your agent, which we'll define in 1 second. Here we put the metrics, the experiment config, this is how many workers we want to run in parallel, and so on and so forth. This is where things get interesting, where we get here every input from the data set independently. We need to define some logic on how our agent is actually called. And this is the output that Opic expects. As I said, the input, the context used to generate the output, and the expected output, basically the output ground truth. In our use case, to call the agent is quite easy. So first we define a philosopher factory that for a specific philosopher ID defined in our data set, we create the philosopher. We define our input messages, which are everything until the last message, and the expected output message is the last message. And then we just call the agent, which is in this agent.call method, which is not streaming, is just one shot answering, which is perfect for our evaluation use case. And then inside this latest state object, we have our context, which is basically our conversation and what we retrieved from the vector database. And now we can call this script basically using this evaluate agent make command. I will just put 2 samples to make this run fast. But basically here you control how many samples from your data set you want to use. Okay. So yeah, while this runs, let me just quickly explain. So here, in the latest state, as I said, we actually have everything that we care about to generate the final answer. So the state is actually controlled by us in this workflow, that state.py file, where we have this pydantic object with the philosopher context, perspective style, and the messages. So this is enough in our use case to see that, okay, based on this specific context, is our answer relevant to the context? Do we have enough context to answer the specific question? Is our context relevant to the specific question? Like basically context precision and recall. And we did that through these LLMs judges. And now we can go to experiments, filter out by this data set that we just computed, and we can see these 2 data points over here. And we have like a score of 0.7 on recall and 0.6 on precision. Not great, not terrible, right? And now we can, for example, increase the number of samples to see some movement, and we compute this again. But meanwhile, I want to show you really quick how this context recall and precision are computed. So if you dig deeper into this, you can see that it's just a simple prompt that guides the LLM into how to compute the score. But let me just quickly find it. Template. Yeah, so here. Okay, so yeah, as I said, it's just a simple prompt that defines that, okay, based on specific scenarios, on how the dynamic between the input context and output is, gives these scores, right? So a score between 0 and 1, where 0 is bad and 1 is good. So usually this is how these LLMs judges work, but the trick here is in the prompt itself, and you want to play a lot with how you define when you should give this interval or this interval, right? So yeah, that's not that simple to do. So afterwards, after you do this, you can basically see how this starts to change in time. And every time you add a new feature, you can see that's for specific metrics, it improved or actually made this worse. Okay, so now let's also, now basically for module 3, we just have to evaluate the whole agentic system as a whole. And to do that, we can just plug in here these metrics which evaluate hallucination, moderation, and answer relevance, right? So this is like basically check if your agent gives correct answers. Just let me run this again, and while it runs, I can quickly explain what happens. So for hallucination, basically it checks that is your answer grounded in the context? And if it's not grounded in the context, it will just give a specific hallucination score. The answer relevance checks if your answer is answering the whole question or some gradient between that, right? Again, a score between 0 and 1. And moderation checks if it's your answer is like in check, right? So it doesn't introduce any racism or things like that. And you can always like implement your own specific metrics. Like what I usually do is just understand how this LLMs judges prompt templates work and like copy paste one and start tweaking them and implement them my own, very specific to my domain, to my use case, and so on and so forth. So it's easy, really easy to plug in your custom metrics. This is, I think that these out of the box metrics are just to get a sense of it, and then you can start digging into your own. Okay, so again, now we can see all the other metrics and start monitoring this in time. Okay, so basically now we have module 2, 3, and 4 in place. Yeah, we have this. Actually, we can also do prompt versioning, but let me quickly do that because I personally think it's really interesting. So to do prompt versioning, again, it's quite easy code-wise. So we just have to wrap our prompt as a string inside this OP class. But to do that and not uh, make it complicated into your code, I usually implement a wrapper class. And based on if you want to add OPIC inside your code or not, when you actually want to access the prompt, you either return the version from OPIC or just directly the string. So like this, when you access the prompt inside your code, you don't care if it's version or not. You don't change the code at all. You let this class take care of this. And now, for example, we track this philosopher character card prompt template. And as you can see here in the prompt library, you have this ODC C, and we have version 4 prompt with some commit history. And I don't know, just let me let me add something, and let's call the agent again. So now the code will pick up on this change, and it will introduce a new version and a new commit. So like this, we can always track the changes in our prompts. 1 second. Okay, so let us actually use the other query with Turing. So now we should see another prompt template. So, okay, so why is this powerful? Because, for example, in the experiments, if we go to a specific experiment, here in the configuration, we can actually see what prompt was used, right? And we can also see like the model, the dataset name, and all of that. So we can track all of this. And also, if we go to here, we can see like this prompt in what experiments is used, and we can revert to various previous versions, and so on and so forth, right? So the last one has this some string introduced here, very, very creative. Okay, so the last phase is to actually really quick show you how to do user feedback while you're like still inside your internal engineering process, how you can really easily flag what's good and what's bad, and so on and so forth. To do that, it's quite easy. So you go to configuration and you have to manually define this, for example, correct feedback item. So let me delete it and create it. Create new feedback definition. So the name is correct. We put it categorical, where yes is 1 and no is 0. As you can see, you can actually introduce whatever you want here. So this is just a very naive example, but it can take you quite far. Okay, so we have this correct option with no and yes values. And then we can go, for example, to our projects. And here where we see all our calls, both from evaluation and when the agent was called, let's just click on the latest one. And actually, let's quickly look through this No. So we have this feedback scores over here, and here we just click on this, and we can, based on, okay, for this specific input, we got this specific output, decide if it's correct or not. Let's say that it's correct. We can also put like some quality value or whatever makes sense for us. So basically here we also labeling all these prompts, right? So we can later on, as we test out the application, we can also build up a very specific data set, which can further use for fine tuning, like preference alignment or some fine tuning on a specific domain and task and so on and so forth. So we start creating data sets, which is, I think, the most powerful thing we can do right now in AI. Okay, and the last thing I want to show you is to check that if for this question, like, what is your view on ethics when it comes to build intelligent machines? And also tell me more about the Turing test. If it picks up on, okay, these are two different questions, should I retrieve twice the context based on these two different questions, right? So it actually did this time. So we can see here in the retrieval philosopher context tab that it retrieved the tool twice. It accessed the vector DB twice. So once it queried ethics in building intelligent machines, and the second time it queried the vector DB for the Turing test, right? So this time it retrieved correctly. And ultimately, I think that here in the last conversation node, we can see the output, and we can see the final output of our question. So yeah, I think we wrapped up for today, and we are open for 2 minutes of Q&A if there. Can you provide some specific examples or scenarios when precision and recall are prioritized from one another? What are metrics to discard results or adjusting the LLM? So for the first question, let me make a different query to the vector database. So I think that here, this is the classic precision and recall trade-off, and it's very specific to your business use case. And for example, if accuracy is critical, you should always prioritize precision, right? So for example, in things such as medical care or legal or whatever, where you want to know that it's better to be precise or just say, I don't know, that's where you want to prioritize precision. So if the context is not enough, don't get creative, just let the LLM tell, I don't know. And in recall, you can be like, I don't know, in writing or generating stuff, you can get more creative and just let the vector memory be more loose and just increase the number of chunks that you get from your vector database with the hope that you retrieve more interesting stuff.